Gas training, Idealogic blocked burner. My name's Alan Hart, and in today's video we've got a friendly Ideal Boilers engineer, and he's going to go through how to test for a blocked burner on an Idealogic combi boiler. This video is designed to, rather than just give you the answers, it's designed to show you how to find the answers. And this is a detailed video from the Ideal engineer. He's done many videos for us now, which, you know, totally appreciate that. Without further ado, let's go over and see this video.
Hello YouTube. I'm back with another back of the van edition. Today I want to follow on from the last video I did on injectors and Venturis, and the one before that was about fans, and a previous video I made was about ionization, flame detection. I want to kind of bring all them videos together, because I think this next one I'm going to do today kind of brings everything together. It talks about something that I've kind of figured out myself, really, and it's how to test for a blocked burner. I spoke about in the last video that once you get air particulates or anything else stuck in a burner, that you ain't going to get it back out, and it's difficult to test whether the burner's blocked or not. On an atmospheric burner, an old standard efficiency boiler, you can literally visually see the burner, the flame picture. You can test the pressure on P2 on the gas valve. You can even adjust it. You can take the burner out, clean it with air duster or a hoover. You can't really do that with a condensing boiler burner, and they're very difficult to figure out whether it's blocked or not. So what I'm going to do today, I'm going to tell you how you can check whether the burner's blocked or not. And this isn't something that you'll get from an Ideal training day, or you won't get this from ringing technical helpline. And I didn't get this information when I did my training. This is something I figured out myself. But I want to share it with you, and I think it might help. So I've drawn a picture here. I don't know if you can tell, but this is the gas inlet to the fan, the injector. This is the Venturi, the fan. This is the burner here. This is the baffle plate. This is the ceramic plate. This is the gas flame of indicator. You know, full burner into minimum burner. This is the heat exchanger, sump, flue manifold, condensate. These are the waterways within the heat exchanger. I tried to depict cool water coming at the bottom, and as it gets to the top, it gets hotter. I've even gone about showing you that the heat exchanger is split in two halves, so when the return comes in, it splits two ways, and the waterways are smaller at the bottom, get larger at the top. They reconvene at the top and then come out the flow pipe. I've even gone to town on this picture, but enough about that. What I want to tell you, and this is the detection probe, which is what we're going to talk about here, and how we're going to test to see whether the burner's blocked and test the burner pressure through. And how this came about, firstly for me, is I went to a Logic which was a year old. Pour hot water. Hot water was just lukewarm, it wasn't getting hot at all. So I did obviously the electronics tests. I think they call them TB118 these days, just to make sure there's no wiring issues. It wasn't. I always start from the basics. I did working pressure, that was fine. And then because it was a temperature hot water issue, I went down the route of looking at the thermistors and the wiring harnesses, and they were fine. Circulation problems, so I checked the pump, whether it was weak. I took the plate heat exchanger out, see it was blocked, the hydraulics. Everything was fine. It just wasn't getting hot. It wasn't even getting to the 35-degree temp diff, and I was just getting a bit baffled. And you know, hot water temperature problem. I was looking, well, I thought I was looking in the right direction, and everybody, I think, would do the same, but it kind of dawned on me after a while. Even after I took the burner out and looked at it and see if the heat exchange was blocked, and couldn't see anything. But what I did notice, there was cat hair all inside the boiler. I mean, it was full of it, and the rubber bung that you use to test the fluid integrity, that was missing. But I didn't think anything of it at the time. I just cleaned all the cat hair out of the boiler, and it come to light that the customer's cat sat on top of the boiler and lived there, and you know, just slept there. But I didn't think anything of it. I was getting frustrated. I was thinking, why is it not getting hot? And then I thought to myself, the only thing I haven't checked was burner pressure. If I go back to a standard efficiency boiler, you know, I've done everything, working pressure, everything. You know, the thermistors, the harnesses, the circuit board, the heat exchanger, plate heat exchanger, all. I had the temperature clamps on everything. And I thought to myself, on an atmospheric standard efficiency boiler, I could check the burner pressure, and I can't on this. But then it dawned on me that I've done so many of these ionization probes before. I know the readings, what a boiler on minimum fire I should be getting through ionization, which is 3 microamps on a logic, and depending on the logic, if it's 24, 30, 35, I know the maximum reading. So I've written it down here. So if I have a 24 kilowatt boiler, and this is not, like I said, this has not come from the ideal, so you won't get this, but I've just learnt this over time. And it's roughly speaking, if I have a 24 kilowatt boiler, the minimum microamps on, you know, low fan speed, low minimum rate is 3. Maximum should be 6 when on max fire. They're all 30 kilowatts 3 minimum, 35 is 3 minimum, but 12 microamps. If I've got the boiler on max, you know, service mode max, I should be getting 12. I should be getting 9 on a 30 kilowatt. So what I decided was, I mean, I was running out of ideas. I'd even taken the burner out and I couldn't see anything in it, but this was a 30 kilowatt boiler I was on, and I put it into max. I was only getting 5 microamps. I put it into hot water and I was only getting 5 microamps. So that told me that there's something wrong with the burner. I swapped the burner and it worked. Literally the boiler, the hot water was red off. What happened, obviously, after speaking to the customer, this cat lives there. The bung was removed, and it was just sucking cat air in, and it got stuck in the baffle plates, between the baffle plates here and the ceramic plates there, and it just blocked it up. So we wasn't, you know, rather than on maximum, we weren't getting a flame like this, we were getting a flame like this. So when I swapped the burner, it worked. And from then on out, when I've come across this problem before, when you're getting poured hot water, and you know, 9 times out of 10, you'll probably find a plate heat exchange is blocked, or the pump's slow, or the thermistors are out. But if they're not, this is where you should be and could be looking. So I thought I'd bring this to your attention, and it might help somebody, because this is a problem that I figured out by myself, and it does work because I've done it. Since then, since I've worked it out, I've applied the principle since then, and obviously you need a clean probe. So before you do this, make sure you change the probe, or that probe is there's no carbon on the probe. And I've done a video on how to test this. I'm not going to go over it again, but pretty much all you do is get your multimeter, set it to microamps, which is that symbol, which is that symbol there. You put your black probe on your multimeter there. You disconnect this lead, so there's a disconnection point. You put that one there. You fire the boiler and you measure the microamps on maximum rate. On a 24 kilowatt boiler, you should be getting roughly around 6. It won't be bang on, it might be 5.5, 5.9, but somewhere close to 6. On a 30 kilowatt boiler, you should be getting about 9. And 35, 12. If you're getting readings like half of that when you're running it, more than likely your burner's blocked. I apologise for how long it's taken to explain this. I've had some comments in the past saying something like "get on with it" or "man, that was boring," and I appreciate the long, but I'm trying to explain in depth of how things actually work, because if you don't understand the actual process and of how they work, and there's no point telling you that you just do this, because you're not really learning anything. I've seen channels on YouTube. I mean, these are even training channels. I've seen at least 4 different ones, like from 4 different training centers on YouTube, putting videos out, making videos on things that are wrong. I found that, you know, they're not telling you detailed information, and they're telling you wrong information. I'm not saying they're all wrong. Most of the time they're right, but some of the things they've said and how they're telling you how things work or how to test them, they're just wrong. So I appreciate it's long, but I'm trying my best to get the information across the best I can, and hopefully this will help somebody, because it does happen. Once that burner's blocked, you ain't unblocking it. And like I said, the way to test the burner on a condensing boiler is very, very difficult, but I've figured out a way to do it. And yeah, give it a try if you're stuck. Okay, thank you for watching. Bye bye.
Thank you very much for that, Mr. Ideal, and thank you for all your help and support with the channel, and also trying to pass your knowledge on to other people. It's really appreciated. I always learn loads from watching your videos, so I appreciate that personally. So yeah, if you've got any questions, please put them in the comments below, and thanks for watching.